Last episode ended on a trap, and it was a trap on purpose. A network reached every single dot correct in 35 steps. 100%. 200 out of 200. It sounds like the best possible ending. Here's the part that got glossed over to get there. Every accuracy this whole series has shown you, 88%, 95, all 200, came from asking the network about the exact same dots it had just been trained on. That's not a meaningless number. A network that can't even get its own homework right has learned nothing at all. But it's a different question from the one that actually matters. What does it know about it that it has never once seen? Every episode so far, that question was never asked. Not once. So today, for the first time in this series, it gets asked. And the answer costs the network almost everything it appeared to have. Same 200 dots as always. 2 moons, interleaved, the same noisy measurements since NN02. Same network. 2, 8, 8, 1. 105 numbers, seated exactly like before. Same optimizer, same step size, atom, at 0.1, the exact setting that got every dot right last time. One thing changes. This time, it only trains on 12 of the 200. 6 from each moon, spread evenly around the shape, not bunched into one corner. The other 188 are set aside completely. Not one of them ever appears in a gradient. 105 numbers, free to move however they like, to satisfy 12 data points. That's close to 9 numbers of freedom for every single dot. They exist for exactly one purpose. To be asked about, honestly, afterwards. Start it anyway, and watch 2 numbers at once. How it does on the 12 it can see, and on the 188 it can't. At the start, 67% on its own 12. 74% on the rest. Barely better than calling every dot the same class. Give it a few steps, and both numbers move. Not just the one it's allowed to study. The hidden number rises too. By step 24, the 12 are perfect. All 12 exactly right. And on the 188 it has never touched? 82%, up from 74. That's real. A boundary shaped by 12 points is generalizing to 188 it has never met. Which is exactly what makes what happens next worth taking seriously, instead of waving away. Step 29. 5 updates later. Still perfect on its own 12. On the held-out set, validation loss. How wrong it is, on average, about dots it's never seen, is 0.39. That is the lowest that number will ever be. Not at the start. Not at the end. Right here. Accuracy on those 188, 87%. Also close to the best it will ever manage. If you stopped training at this exact step and shipped it, this is what you'd be shipping. Here's one of those 188 at this exact moment. True answer, the outer moon. The network gives it 57% for the inner moon. Wrong, but barely. A coin flip that landed on the wrong side. Nothing in the training loop knows step 29 was the best moment. Nothing tells it to stop. So it keeps going. Step 40. Step 80. All the way to 4,000. On its own 12, there's nowhere left to go but down, and it goes there. 0.07 at step 29, down to 5 millionths of a point by step 4,000. As close to 0 as this computer bothers to represent. Cross-entropy never actually hits 0 unless a prediction is exactly 0 or 1, so there's always a little more of it to squeeze out, forever, on the same 12 fixed points, with nothing left to do with the other 188. The total size of its weights tells the same story. 11.7 at step 24, 23.1 by the end, practically double. It isn't finding a better shape. It's the same shape, pushed harder, sharpening around 12 exact points, because nothing in the loss function rewards a smooth line through the gaps between them. Watch that one dot again. 57% wrong at step 29. By step 40, 85% confident, the wrong way. By step 80, 97. By step 4,000, over 99.9%. Not leaning wrong anymore. Certain and wrong. That single isn't a cherry-picked accident. Zoom back out to all 188, and the average does the same thing. Validation loss, 0.39 at step 29. 1.22 by step 4,000. 3 times higher. The network has gotten measurably, provably worse at describing dots it never trained on. Now here's the number that should actually worry you. Validation accuracy at step 29, 87%. Validation accuracy at step 4000, after all of that, 88%. It didn't fall. It's a hair higher. If accuracy is the only thing you're watching, step 4000 looks fine. Slightly better, even. Loss is the one screaming that something is wrong, because loss punishes confidence, and plain accuracy doesn't measure confidence at all. That gap, a score that looks fine, sitting directly on top of a network quietly getting less trustworthy, is the entire reason anyone bothers holding data out in the first place. The practical version of this has a name. Early stopping. Stop at the best point on data you held out. Never at the last step, and never by watching training loss. Training loss always looks good if you just wait long enough. So which is it? A network trained for too long, or a network with too few points to begin with? Change exactly one number and find out how many of the 200 it actually trains on. 12 training points, same everything else. Validation loss triples, 3.15 times worse, in versus best. 50 training points, same network, same optimizer, same 4,000 steps. Validation loss rises 1.82 times. Milder, still real. 100 training points, half the set. Validation loss at step 4000, and validation loss at its very best point, round to the exact same number. It never got worse at all. Nothing changed except how many real examples it had to learn from. 3 times worse, then less than twice, then not at all. So it's both, and neither one alone. Training too long is what causes it. How much data there is decides how much room that damage ever gets to happen in. So, a network scoring 100% has told you exactly one true thing. It scored 100% on the questions it was allowed to study in advance. Whether it learned the actual shape or just memorized 12 points is a completely different question. There's exactly one way to answer it. Ask about data the gradient never touched. Training loss can only ever fall. That part was never in doubt. The number actually worth watching was always the other one. We've now watched a network learn one weight, follow a gradient downhill, bend a straight line into a curve, get scored by the right rule, pick the right step size, and know exactly when to stop trusting its own scorecard. None of that has actually explained how one mistake, made at the very end, finds its way back to a single weight buried deep inside. That's next. The walk backward through every layer, credit assigned one exact number at a time. So subscribe to ZapBite AI and watch the correct